Howdy, nerds and losers. My name is Evan Colin, and I would like to introduce you to my idea for a machine learning insult generator. So how does it work? Well, there's two main components. We have a visual component and we have a writing component. But first, let's discuss the similarities between the two. Both of them are going to use a model. As you can see on the right here, this is a visualization of the model, where the dark blue squares are the input, the light blue squares are the output, and everything in between is how it gets there. You can see on the left a bunch of different layers, which are represented by these columns of circles. And each layer contains a piece of information, and slowly it combines more and more pieces of information, be that words or be that pixels. And as it strings these pixels together, it creates a full image and realizes what it's looking at. Everything's going to follow this graph on the right. You have some sort of data set, you have a pipeline of information, the training pipeline gets fed to the model, and the model learns based on the information that you give it. And at the end, it does testing using the validation pipeline. The data set, in our case, would look like a bunch of faces that represent a wide portion of the population. Again, I have the model on the lower left. Looking at the visual component, what it's going to do is it's going to learn, okay, this is a nose, this is an eye, this is an ear, and it's going to compare them. It's going to look at the sizes and the ratios compared to the rest of the head. In this case, we look at the nose. A nose should be about 1/5 of the face in width, and this one's is. So it would say, okay, this is not something that we're going to insult, but it would continue this process until it finds something that it would want to insult. But how does it do that? Well, that's where we're going to look at the training pipeline. So the training pipeline in our case is going to have two pieces of information, classification and localization. Where classification is saying, this is the thing that I am looking at. In this case, it would be eye. You can see eyeball.txt in the middle right of the screen. The first piece there says eye. That is our classification data. The rest of the data is localization data, which is the red box drawn around eyeball.jpg. And that is how we know where the object is, and is how we'll determine what size it is. Then on the bottom right, you can see a code with classifier branch and locator branch, which splits the data inside of the model between what is classification data and what is localization data. This is code that I used in order to split the data and feed it to the model. Now, what we'd really get is something that looks like this, where there's a super busy image that we can't really see, but the model would be able to understand what's going on. It looks at everything, and in this case, it would say, okay, well, the distance between the eyes on average is 23%, but ours is only 19%. So we'll determine that the eye distance is small and we'll insult it. And now that we know what we're insulting and how we're going to insult it, we need to decide, what do we write? Well, the writing component is going to use something called natural language processing, or NLP. And it is fundamentally the same idea, but the information that we feed it is going to be different, where we have three main pieces: noun phrases, verb phrases, and prepositional phrases. Combined all together, it is called context-free grammar. But a problem that we run into is that words can have multiple meanings. A prime example of this is the sentence, I shot an elephant in my pajamas. Well, was I wearing the pajamas, or was the elephant wearing the pajamas? This is handled by using a parse tree, which takes all of our three forms, NP, VP, and PP, and shows the varying options and meanings. So if there are multiple meanings to a sentence, it will show you all the different meanings, and you can decide which one that you want to use. And this introduces a bunch of complexity, but we have hope in our case in that we're using it in a very limited use. Broad language understanding isn't necessary, just a focused task of insulting one object based solely off of its size. So, with a sentence like, they have a big brain, we can assume that we are commenting on the physical size of their brain and not on their intelligence. And then once we have what we're going to insult, it's not easy to train the model to say, okay, this is right or this is wrong. Because before, we could say, well, you classified it as an eyeball, and it is indeed an eyeball. But how do you look at a sentence and say, yep, that's the correct sentence? So you can feed it to a large amount of people. You can say, okay, well, company X, we'll give you our project, and you're going to help us train it. And in turn, you get the software for free, or at a greatly reduced discount. My personal idea is to introduce the idea to Snapchat and have thousands of users use the insult feature on friends, and that way I'll receive thousands of training results that the model can use to improve its performance. So altogether, we're going to get something like localize the face, classify the face, find all of the sizes, calculate the ratios, find what we're going to insult, in this case the eye distance, which is small. We create the parse tree, and we come out with an insult. In this case, it would be, your eyes are so close, you could use a telescope as binoculars. This is what the parse tree would look like. So in conclusion, by combining two different types of machine learning techniques, we can create a more complex system that can comment on the real world. If scaled, this project could be used to describe more meaningful things and even non-physical things like relationships between objects. Additionally, with more power comes more responsibility. An ethical duty lies with the creator to make sure the program runs within the rules of society, because while it is made to comment on physical appearance, it should not insult someone based on skin color, religion, or ethnicity. Hopefully, you'll see this on your Snapchat filters in the next few years. Thank you.